Hello guys, so we are back again, and in this session we are going to do some more questions on Lagrange method of multiple variables multipliers. In the previous session we have solved 3 questions based on Lagrange method and hope you have revised them. But before starting with the session, hope you have subscribed the channel Omega Pi IDJ and Git so that you can get updated with the latest video lectures which we bring, and do share it with your friends which are in engineering or which are pursuing their engineering degree so that they can secure good marks in their examination. Now the question which we are going to take in this session is this question: find the maximum and minimum distance of the point 3, 4, 12 from the sphere x square plus y square plus z square equals to 1. Now they have told the maximum and minimum distance of the point 3, 4, 12. So there is a point 3, 4, 12 in the space, and we have to find the maximum and minimum distance of it from the sphere. Now we have to consider some point x, y, z on the sphere. Take the distance from 3, 4, 12 to x, y, z, and then minimize it or maximize it. So that is our job. So this thing is for sure by implicit function property, it is our phi. So what we are going to do, let p x y z be any point on the sphere. What is a sphere? X square plus y square plus z square equals to 1. Distance, okay, distance of point p x y z from 3, 4, 12 is d. Therefore d is equal to under root. Now there in the last lecture we take the distance from origin, but here we are taking it from 3, 4, 12. So the formula will differ. It will be x minus 3 the whole square. I have told you there also, the whole square, and z minus 12 the whole square, and phi equals to phi x comma y comma z. You can say it f of x comma y comma z is equals to d equals to this thing, and phi equals to this, which is x square plus y square plus z square minus 1 equal to 0. Now stationary point are obtained by solving dou L by dou x equals to 0, dou L by dou y equal to 0, dou L by dou z equal to 0, and dou L by dou lambda equal to 0. Right? Now consider the Lagrange function, which is our next step. Okay, we forgot to do that step. We did this step, but never mind. Just remember that this step will come before it. The steps are very important. You have to keep the sequence of the steps in your mind. So if I do this x comma y comma z plus lambda times phi x comma y comma z, right, which x minus 3 the whole square, y minus 4 the whole square, z minus 12 the whole square, and here lambda times this is what, this is nothing but x square plus y square plus z square minus 1. So we are done with this. Now we are going to get these values and then solve it. So dou L by dou x is what? It is 2 times x minus 3 upon 2 times under root x minus 3 the whole square, y minus 4 the whole square, z minus 12 the whole square, plus 2 lambda x equals to 0. Right? Now this will cancel out, and we can, or remember, if you can remember, this under root stuff is nothing but d. So we can write it x minus 3 by d plus 2 lambda x equals to 0. Now here what we are going to see, that we can get x, if we solve x minus 3 is equals to minus 2 lambda xd. Therefore x into 2 lambda d plus 1 equals to 3. Therefore x equals to 3 upon 2 lambda d plus 1. We will call it as 2, and we will call it this one as 1. Now similarly, dou L by dou y will be what? Y minus 4 by d plus 2 lambda y equals to 0. Therefore y plus 2 lambda yd equals to 4. Therefore y equals to 4 plus 1 plus 2 lambda d. We will call it as 3. Now dou L by dou z is nothing but z minus 2L by d plus 2 lambda z equals to 0. Therefore z into 1 plus 2 lambda d equals to 12. We are getting z equals to 12 upon 1 plus 2 lambda d. So we got this thing. Let's call it as 4. Now we are going to move on to dou L by dou lambda, which is nothing but z minus if we differentiate it, we have x square plus y square plus z square minus 1. If I substitute, put x, y and z, all these values, z value, y and z value from 2, 3 and 4, we have 3 by 1 plus 2 lambda d the whole square. Lambda d the whole square plus 4 upon 1 plus 2 lambda d the whole square plus 12 upon 1 plus 2 lambda d the whole square is equals to 1. Therefore if we write it, 9 plus 16 plus 144 is 1 plus 2 lambda d the whole square. Therefore 169 if you add on is equals to 1 plus 2 lambda d, so the whole square. If I move it, I have 1 plus 2 lambda d is equals to plus minus 13. So we got this thing when 1 plus 2 lambda d is equals to 13. We get x equals to 3 by 13 and y equals to 4 by 13 and z equals to 12 by 13. How you get that? Okay, I am not going to do it again and again. It is very simple. You just need to substitute all the values here. It is just straightforward thing. So I am not going to write the whole stuff, which is 1 upon whole 1 plus 2 lambda, which is just wastage of time, right? And when 1 plus 2 lambda d is equals to minus 13, we are going to have x equals to minus 3 by 13, y equals to minus 4 by 13 and z equals to minus 12 by 13. Okay, so stationary points are, what are the stationary points which we have? 3 by 13, 4 by 13, 12 by 13 and minus 3 by 13, minus 4 by 13, minus 12 by 13. So f of 3 by 13, 4 by 13, 12 by 13 is equals to under root what? 3 by 13 minus 3 the whole square plus 4 by 13 minus 4 the whole square plus 12 by 13 minus 12 the whole square. If I calculate, what is the value? 3 minus 3 is 14 minus 12, 30 minus 3, 12. Okay, and f of minus 3 by 13 minus 4 by 13 minus 12 by 13, we are having minus 3 by 13 minus 3 the whole square by 13 minus 4 the whole square plus minus 12 by 13 minus 12 the whole square is equals to 999. So we are having if I 13 14. Okay, so we are having 14. Therefore maximum value is 14 and minimum value is what? 12. So we are done with this problem. Now let's move on to the next problem. Hope you have understood each and every step properly. The question was quite lengthy, I will admit that, but it was very important question. It was just a modification of the last question which we did in the previous session. So we have understood each and every step. Just you need to be careful in taking the distance, and then rest of all the things are same only. Now let's move on to the next question. The next question is this question: find the maximum value of f of x comma y comma z equals to xyz subject to the constraint. Okay, so here they have directly told you what you have to do. So let f of x comma y comma z equals to xyz, they have given you, and we know phi xyz. They have given straightforwardly by telling constraint 2z minus 108 equals to 0. Since they have mentioned constraint, so we can directly make out. There is no issue in this. Consider the Lagrange function. So if I consider the Lagrange function, L equals to f of x comma y comma z plus lambda times phi x comma y comma z, what we are going to have is xyz plus lambda times 2x plus 2y plus 2z minus 108, which is what? 1. Now stationary point are obtained by solving what? Dou L by dou x equals to 0, dou L by dou y equals to 0, dou L by dou z equals to 0, and dou L by dou lambda equal to 0. So dou L by dou x, if you observe, is yz plus 2 lambda equals to 0. And here, now here you know v is what? V is the maximum value of f of x. So this is whatever, if it is f of x, okay, we can consider something. Okay, if we consider it some function, like here we in the previous we consider it like u. If we consider it as v, because xyz is probably a volume like thing, so if v is equals to xyz, so then I can get yz value as v by x. Now let v equals to this thing, then v by x equals to y by z. So dou L by dou x is equals to v by x plus 2 lambda equal to 0. So I can get my x value minus v by 2 lambda. Call it 2. Dou L by dou y equal to 0 is nothing but xz plus 2 lambda equal to 0. Similarly here you can write vy plus 2 lambda equal to 0, which will give you vy equals to minus v by 2 lambda, which is 3. Now let's go for dou L by dou z. So dou L by dou z equals to 0 is what? Xy plus y lambda z equals to 0, which I can write as v by z plus 2 lambda equal to 0. Sorry. Okay, just let me see. Okay, 2. Now what we can do here, if we simplify it, we are going to get z equals to minus v by 2 lambda, which is our fourth equation. Now dl by d lambda equal to 0 is what? Is 2x plus 2y plus 2z minus 108 equals to 0. So if I substitute here all the values, minus v by 2 lambda plus 2 into minus v by 2 lambda plus 2 into minus v by 2 lambda minus 108 should be equal to 0. So minus 3v by 2 lambda. Here it will be 2 means 6, and 2 lambda is already, so 3 by lambda. 6 by 2, okay, 6 by 2, so it will become 3v by lambda equals to 108, giving you b by lambda value as minus 36. We can put it here. So when v by lambda is equals to minus 36, So x equals to what? Minus 1 by 2 v by lambda. So it will be nothing but minus 1 by 2 into minus 36, which is nothing but 18. Y equals to minus 1 by 2 into v by lambda, which is equals to minus 1 by 2 into minus 36, which is what? 18. And z equals to minus 1 by 2 into v by lambda, which is nothing but minus 1 by 2 into minus 36, which is 18. Therefore, stationary point is 18, 18, 18. Therefore, minimum value is, what is the minimum value? Is f of 18, 18, 18, which is 18 into 18 into 18, which is 18 cube. 18 cube is what? Let me calculate. What is it? Okay, 18 cube is 5832. So we are done with this session. We calculate the maximum value of the function which they told us to maximize. So in this session we did these two questions. Revise this question properly and solve it again so that you get the clear and conceptual understanding of Lagrange method of multiple multipliers, undetermined multipliers. So thanks for watching the lecture. See you in the next lecture.